Welcome to the sections on complex numbers. Any real number squared is positive but cannot be negative. So these questions does not have any real number solution. So since it doesn't have one, so we're going to invent one. And we're going to call square root of -1, the negative sign, to be the symbol I. And so therefore we square the I again -1. We can use this I to make up answers for questions like whose number square is a negative R, and then the answer is that we can pull the I's out. For instance, one number square is -49, and we get the answers as ±7 times I. And using this I, we add them to the original real numbers we have. Now we have answer, we have n numbers with two parts, the real numbers and the complex number, the real imaginary parts. And all these are complex numbers. And we add complex numbers by treating the I parts like variables. So 4i minus 3i become plus I. And the interesting things about the operation of complex numbers is, of course, the multiplication. We FOIL the multiplication of complex number, then I squared change the sign in front of that terms, in this case, positive 21. Then we combine, we get the complex product. We use conjugates to carry out multiplications. Here's how we do it. These a plus bi, a minus bi, I call conjugate pairs. And when we multiply conjugate pairs, we get the square of the numbers added, because I squared turns the minus into a plus. Okay, so the complex conjugate multiplication is always a positive numbers, and we use complex conjugates to simplify to find quotients dividing two complex numbers. How? We multiply the denominator by the complex conjugates and on the top two. And of course, the denominator now turns to a real number, positive real number. We FOIL out the numerators, and then we wind up with the complex quotients of the divisions. And we can use complex number to write the solution for any second degree equation now by plugging into the quadratic equation. So this one, we get a complex solutions. And notice we use complex solutions, we always get complex answers in conjugate pairs if the b squared minus 4ac is negative. Okay, that's it. Bye-bye.